Here n of A intersection C is equals to 43 plus 37 minus 61, which is equals to 19. N of B intersection D is equals to 37 plus 35 minus 59, which is equals to 13. N of C intersection D is equals to 37 plus 35 minus 35, which is equals to 14. Now N of A union B, B union C union D is equals to N of A plus N of B plus N of C. Here N means cardinal number of A, B, C. So we are separately finding cardinal number of A, B, C and putting in the values of the given formula. Plus N of D minus N of A intersection B plus N of A intersection C plus N of A intersection D plus N of B intersection C plus N of B intersection D plus N of C intersection D plus N of A intersection B intersection C plus N of A intersection B intersection D. Here A intersection means common terms which are in set A, B, D, common terms in set A, B, C. Here we can summarize in this form: A intersection B intersection D. Now plus N of B intersection C intersection D plus N of A intersection C intersection D minus N of A intersection B intersection C intersection D. Now this is the formula for finding N of A union B union C union D. Now putting the values to find the remaining terms. 91 is equals to 43 plus 37 plus 37 plus 35 minus N of A intersection B plus N of A intersection C plus N of A intersection D minus N of B intersection C plus N of B intersection D plus N of C intersection D, which is equals to 5 plus 4 plus 3 plus 6 minus 1. Now moving further, thus we can see here n of A intersection B plus n of A intersection C plus n of A intersection D plus n of B intersection C plus n of C intersection D, which is equals to 152 plus 81, 18 minus 1 minus 91, which is equals to 78. Now number of rats who have exactly 2 genetic mutation is equals to 78. Here we have the mutation number of rats who have exactly 1 genetic mutation. For that, only 1 genetic mutation. This is for 2 genetic mutation, and this is, now we are going to find 1 genetic mutation. So for that, n of A intersection B complement intersection C complement intersection D complement plus n of A complement intersection B complement intersection C intersection D complement plus n of A intersection A complement intersection C complement intersection B complement intersection D, which is equals to 48. So from there are 48 for rats who have 1 genetic mutation and 78 rats who have 2 genetic mutation. Now probability that 3 will have exactly 2 genetic mutation will be probability that 3 will have exactly 2 genetic mutation is 78 upon 3 plus 22 upon 6, or we can say divide by 6 whole divisible by 100 upon or 100 divisible by 9. This is the probability. Moving further, this is our part A. Now for part B, 8 rats are selected from population probability that no more than 2 will have exactly 1 mutation. For that, we are going to solve 48 upon 0 into 52 upon 8 whole divisible by 100 upon 8 plus 48 upon 1 into 52 upon 7 whole divisible by 100 upon 8 plus 48 by 2 into 52 upon 6 whole divisible by 100 upon 8. This is our second part's answer. Now for the C part, we are going to solve. 8 rats are selected from the population probability that at least 7 will have exactly one mutation. The probability will be 48 upon 7 into 52 upon 1 100 upon 8 into 48 upon 8 52 upon 0 upon 100 upon 8. So therefore we can say probability of part A and B is different.